So hi everyone, how you guys doing? First of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, and on this particular channel, every concept of physics, chemistry, and maths are being taught to you completely in English. Now, this is a series that I host for class 11 students, and the topic that we are discussing right now is fluid mechanics, and this is lecture number 2, and we'll be discussing fluid statics today. All right, before we get started with today's discussion, let me introduce myself for those of you who might not know me yet. So my name is Rohit Dixit and I studied mechanical engineering from IIT Delhi. And for almost past 8 years, I've been teaching physics for the IIT JEE Mains and advanced examinations. Now, all this teaching experience of mine so far, I've been offline, and this is my first online venture. All right, I myself was All India rank 447 and All India rank 192 in the two stages of the IIT JEE exams that I took. Now, I also qualified the NTC Stage 2 as a student, and I was in the top 1% in the NACP. Now, I've already coached many students to top ranks in the IIT JEE examination, and now I hope to continue doing that with you guys here online. So, as I said, before this year, all my teaching before the lockdown had been in the offline setups. So, the new situation, the lockdown has forced all of us to adapt. So I had to move online. Hello, Rajesh, how are you? So similarly, you students can also do the same thing in order to ensure that your studies are going ahead uninterrupted and smoothly. You can get yourselves the Unacademy subscription. Now, this subscription will give you benefits like live classes, where you get to interact with your educator on a regular basis. Now, you also have live polls and leaderboards in these classrooms, which keep them quite interactive and very efficient. Now, you also have test series and analysis sessions, which again are very important for a competitive exam like JEE to keep you on your toes and keep you aware of your standing. And of course, you have live doubt clearing sessions. So again, a huge advantage because in all Unacademy Plus courses, every fourth session is supposed to be entirely dedicated for your live doubt clearing session. All right, so after every three teaching sessions, one session is completely dedicated for doubt clearing so that your doubts, be it about theory, be it about question solving, they never go unanswered and they don't pile up. Now, on top of all these benefits, you are also getting the chance to study from the topmost educators in the entire country from the comfort and safety of your home. So these features, I think, make a wonderful opportunity, present a wonderful opportunity for all the students looking to prepare for this competitive exam. So how can you avail all these benefits? The first step is to install the Unacademy app. Now, the moment you do that, you unlock yourself a lot of free features, which are there are free courses that happen on the Unacademy app. You can enroll in those. Okay, just after installing the app, you don't even have to get the subscription. Plus, you can watch special classes. Okay, so special classes are there. These are available absolutely free of cost. Again, all you need to do to access these is just install the Unacademy app. And finally, you have live quizzes like the one we keep having every Tuesday. So all these features are available absolutely free of cost just after installing the Unacademy app. So make sure you do that and get use of these. Now you can unlock all these features by using my code, which is RD Live. Okay, so all you need to do is just install the app, put this code, and you have unlocked all the wonderful free features. Now, once you have uh, assessed, you know how your and ARJ, how are you? Hello, AP, how are you? So, and once you have assessed, you know how your plus subscription is going to be, how your studies on with the plus is going to be. That's what those free classes are for. Those will give you some idea about how your plus subscription is going to go. So once you decide to take the finally plus subscription, this is what you can do about it. So you can go to the plus section of the app, select your goal as IIT and click on that get subscription button. Now, the moment you do that, you'll be redirected to the payment page where you will find a box which will say, do you have a code? So don't forget to use this code RD Live. This will give you a 10% off on all your subscription fees. Okay, now you can choose from two kinds of subscriptions, plus and iconic. And also, when you click on proceed to pay, you can choose a payment method which suits you. You can divide your payment into a lot of no cost EMIs. Okay, now, plus subscription, a lot of you guys know, a lot of you don't know about the iconic subscription. So let's tell you about that bit. So the iconic subscription will take your IIT JEE preparation to the next level. And how does it do that? You are allotted personal coaches from a team of experts. So these personal coaches personally guide and mentor you throughout your JEE journey. Besides these, you also attend a lot of IIT workshops. You receive expert guidelines from time to time. You receive a study planner, and you have regular test analysis sessions. All right. Now, if you decide, to get a single one-stop solution for all your worries about your boards and your IIT, now you can go for combo subscriptions also. So there are various combo subscriptions available where you have access to both your IIT JEE preparation and your board CBSC preparation. So these combos are as follows. So there are four combos right now. One with Iconic for JEE plus for board. One for Iconic for all three, one which gives you the chance of getting plus subscription of all three, and another plus for ITJ and Iconic for your boards. So the prices of these subscriptions are as mentioned. Now, again, you can select a plan that suits you, and this will ensure that all your studies, be it about boards, be it about IIT, they are taken care of. All right. Now, another wonderful way of judging your standing in the competition, testing your preparation, and testing your standing amongst your peers is by taking part in the J Unacademy Combat. Okay, so the next event is going to happen live on 17th of January. You can enroll now in that with the code RD Live and compete. And if you do well, then you stand a chance to win a lot of cool rewards and prizes. Okay, those of you who are following us on the JEE English channel of YouTube can connect with us on the Telegram app using this link. This will make sure that you're receiving all the notifications of all these sessions and lectures happening on this particular channel. All right, why don't we get started with the topic of the day, which is fluid mechanics? What happened, ARJ? Why are you in a dilemma? What kind of dilemma is bothering you? So tell me. All right. Okay. Till the time ARJ mentions his dilemma, let's get started with today's discussion. So first, we'll start with a basic concept problem based on the discussion that we had in the last class. Okay, so this question says that at a certain depth in an incompressible liquid, the absolute pressure is P. At twice this depth, what will the absolute pressure be? Will it be equal to P? Will it be equal to 2P? Will it be less than 2P, or will it be greater than 2P? Okay, so think about it and give me your answer. This is a conceptual problem that I wanted to start today with. Yes, tell me. What happened, ARJ? What seems to be bothering you? Okay. So, how about the answer to this problem? So, do think about this problem also and try and give me an answer. Okay. Let's see what you guys think. It's a very simple problem. Okay. Okay, doing plus two in Karnataka board, and there is a chance boards go to May. Okay, and all the exams get postponed. I'm taking KCET, BITSAT, mains, possibly advanced. So the thing right now is, should I do 11th topics or 12th? Okay. So that depends. That depends. How do you think is your 12th preparation, first of all? See, 12th preparation is more important, definitely. Okay, so how are you feeling about your 12th preparation? So if you're feeling about comfortable about your 12th preparation, then maybe for 1 month you can dedicate to your class 11th. Okay, and maybe keep some time for your class 12th revision also. Okay. Then right now just focus on class 12. Okay, just focus on class 12 then. Then do not bother about class 11 so much right now. And till the time you guys think about this problem, let me just be back. I can hear. Okay, so Any answers to the question that I had asked? Hmm. Okay. So nobody has anything to say. Okay, Suraj says C. Okay. So yes, yes, yes. Turns out Suraj is absolutely right. Yes, well done, Suraj. The C is the correct answer. Because at a height h, let's say at a height h, pressure at height h would be P naught plus rho gh. Now pressure at height 2h would have been P naught plus 2 rho gh, right? Which is essentially less than 2 times P. Okay, that is correct. Also, should I rush the topics for Feb means or not? I don't have any issues about understanding the topics, but even if I rush the score, even if I rush and score good in means, I'd have to redo from start for advance. Hmm. So then, of course, do rush it for Feb mains, because as you said, later you are going to have pressure of other exams also. Okay. So I think for mains you should try and focus on Feb and March attempts. Okay, focus on these two, because later you would have your boards and other exams coming up. Okay, so yeah, you may have a lot of trouble later. I would say just try and focus on these two attempts. Try and rush your syllabus. Okay, and try and finish it well in these two attempts. Okay. Hello, Motilal. How are you? Okay. ARJ, and don't worry about it. Just get on with it. Okay. Don't think about it too much. Just start acting. Okay. It's the worrying that is dangerous. Okay. All right. Moving ahead with the discussion then. So this is something that I told you in the last class, that a shape of the free surface. Now, since by definition I told you liquid cannot withstand a shear or tangential stress, so the free surface always aligns itself perpendicular to the direction of the net force that it feels, right? So I told you this, that imagine if you had a vessel like this. I had given you this example, and imagine if the liquid surface also remained like this. Okay, then you would have realized that for all molecules at the surface, you realize they would have felt one mg force, right? The force of gravity. And the force of gravity would have had a component in this direction and a component in this direction. Now, this component of the force of gravity would have provided a tangential stress, and that would have caused the liquid to flow from there to here. So, liquid would have eventually flown from here to here, and it would have started collecting here. So this level would have gone up, this level would have gone down, and eventually this flow would stop only when the free surface becomes like this. So whenever a fluid is there in equilibrium, the free surface always aligns itself perpendicular to the external force. Okay, so that there is no external shear stress. So again, you can imagine this. So what will happen is finally you would have had the free surface level like this. Now the moment the free surface level is like this, now you realize that this mg cannot produce any tangential stress. Okay, so this is how the free surface of a liquid always behaves. Okay, so let's try and find out the angle of free surface of the liquid when it is kept in an accelerated vessel. So imagine now that you had a liquid in a vessel like this. So we'll start with a very simple case. Okay, so let's say this is your container. Okay, and this had some liquid, and you accelerated the container with some acceleration a. Okay, so let's imagine that in your equilibrium, the liquid would have become like this. The free surface would have become like this. So let's say the angle that it makes in this position with the horizontal is theta. Okay, so now there are three ways to analyze this and find the value of this angle. The first way is, as I told you, If you talk about the forces acting on the molecules, okay, if I go into the reference frame of the container, so I can say in the reference frame of the container, what are the forces that liquid molecules are feeling? They'll feel a pseudo force Ma, and they will feel a force of gravity mg. The effective force would be somewhere like this, and the liquid free surface will always align itself perpendicular to the net force, right? So the net force direction I can already tell you. So now if this angle is theta, so you realize this angle will also be theta. Okay. Hmm. Okay. No, no, this angle will be theta. Okay. So I seem to have messed the diagram up a bit. Okay, so these are the two forces that every molecule is full of feeling. So the net force is like this. Okay, and if this angle is theta, then you will realize that this angle would have been 90 minus theta and this angle would have been theta. Now you know the force, the direction of this also. Okay, so this would have been MA and this would have been MG. So I can say that the free surface will align itself perpendicular to the G effective. That is what we are going to call that net force. Okay, we are going to represent it with the G effective. Okay, so and from this diagram, I can see that if you have A here, if you have G here, G effective is nothing but vector sum of these two. So from parallelogram law, I can say that tan of theta would be equal to A over G. Okay, so this is how you find the angle of the surface. Okay, tan theta is A over G. All right. Now there is another way of finding this, by the way. So you could have alternately looked at another approach. So let's take a look at that. Let's take an alternate method of finding out this angle. Okay. So let's say you had this container again. So you had this container like this, and let's say you accelerated this vessel. Okay, so this vessel was getting accelerated like this. Now, you know that when we accelerate a vessel, then the pressure variation starts happening in the x direction also, right? So now the alternate method for me was that if I imagine that this is the liquid surface, and I can say if this was some x, let's say this was some y being this height. Now, what I can say is, what I can tell you is that this liquid, this liquid in here, okay, would have tilted such that if I talk about the pressure, what is going to be the pressure here? So let's talk about this point. So this point is right at the surface. So the pressure here obviously will be P atmospheric or P naught, where P naught is the external pressure here. Similarly, this point which is at the surface will again have a pressure of P naught. So if I go from here to here, and if I want to calculate the pressure of this point A, and let's call this point B, and let's call this point C. So I can tell you now that along the line AB, you will realize along the line AB, I can say that pressure will increase in the direction of the pseudo force, right? So what I can say is PA minus PB would be equal to rho AX. That is going to be my first equation, right? Okay, and PB I know is P naught. So I can say PA equals P naught plus rho AX. That is my first equation. Similarly, along the line CA, what you will realize is that PA is P naught plus rho GY. Correct? Hi Devra Varun, how are you? Now what I can do is I can equate these two. So from equation 1 and 2. So I can say from equations 1 and 2, what we realize is that rho G A, sorry, rho G, rho, rho A X equals rho G Y. Okay, which essentially gives me that A over G is Y over X, and Y over X is nothing but tan theta. If this angle is theta, this is tan theta. Okay, so this is an alternate approach of getting to this relationship. Okay, so you can apply any of these approaches. Okay, both are fine. Just follow the logic. Until the time you're applying the right approach, you shouldn't have any problem. Okay. So this is also another method of deriving the angle of made by the free surface of the liquid in its equilibrium position when placed in an accelerated vessel. Okay, I hope that makes it clear. Okay. Now why don't we start with some problems? Okay, so I have started with a tricky one now. So here you've been told that a rectangular box containing water is accelerated upwards at 3 meter per second. Okay. So I think there was something wrong with that. So I think the acceleration should have been I think should have been, yeah, 10 as shown here. It was 10 meter per second. Okay, so that is the situation shown to you. A rectangular box containing water is accelerated upwards at 10 meter per second square on an inclined plane, making an angle 30 degrees to the horizontal. Now, the slope of the free surface with the horizontal will be. So, why don't you guys try this? Let's see. Okay, try this. Hurry up. Let's see if you can figure this out. Okay, hurry up, people. I hope I've got the values correct. Okay, still, let's see. So what do you guys think? What is going to be the angle? So hurry up, try this, and let's see how many of you can figure this out. So anybody who's trying can just let me know by writing trying in the chat at least so that I know who I'm waiting for. Hmm. Good evening, Raj. How are you? Okay, let me know fast, guys. Okay. So till that time you are trying this, I'll help myself with some water. Okay then. Nobody with any answers. Okay, this is not that difficult also, guys. Come on. All right, let's see. I told you all you need to do is find the direction of G effective. Right. So if acceleration was along this line, right, a with and it was 10 meter per second square. The pseudo force corresponding to this acceleration. Okay, Suraj is fine. Okay, all right. So thank you for letting me know, Suraj. So I'll wait for you. Okay, okay. My says yes, sir. Okay, all right. 0 degrees. Okay, let's see if that can be the correct answer. So if I talk about the pseudo force, so the pseudo force, okay, would be in this direction of 10. This would have been 30, and then there would have been mg of 10, right? So this would have been the net. The vector sum of these two would have been the net force. So I really doubt so that it's going to be zero. Okay, it is not going to be zero. Plus, you had to mention it with the horizontal. Okay, now what you can do is you can divide this into two components. Okay, so you would have had a component of 5 here, and then you would have had a component of sine theta. Okay, cos 5 root 3 here and 15 here. Okay, so now you realize the G effective, and this would have been theta effective. So you would have realized tan theta would have been equal to 5 root 3 over 15. That would have been 1 over root 3. Okay, tan theta 1 over root 3 means theta equals 30 degrees. That would have been your answer. So I think what you did was 0 degree is probably with the incline. Okay, here you've been asked with the horizontal. So 30 is the right answer. Okay, Suraj. So that was a slight mistake on your part because you have given the answer. Yes, I agree. I agree. The thing would probably get like this. Okay, no, not even like this. Let's see. Let's see. It will in fact get like this. Uh, uh, uh. Hmm. It would in fact get like this because the G effective is like this. So the water level would actually get like this, like this. So with the horizontal, if this is the horizontal, then the water level would have been like this at 30 degree like this. So even with the incline, you would have realized it would happen at 60 degrees. With the incline, it would happen at 60 degrees, not not zero also, because it is inclining the other way. Okay. So it would happen 60 degrees with the incline. But you've been asked with the horizontal. With the horizontal, it will be 30 degrees. Okay. All right. Great. So now let's move on. Try another kind of problem. Okay. So let's see. Here is another problem which says a U-tube is rotated about one of its limbs with an angular velocity omega. The difference in height h of the liquid of density rho levels is the diameter of the tube d is much less than L. So this was a question that was asked in JEE 2010. Okay, so this is an actual JEE advanced problem. Okay, let's see if you can figure this one out. If you can figure this one out. Okay, what? You mean this question or the solution of the last problem? Okay. So what I told was that if you have to find the angle with the incline, if you have to find the angle with the incline, you realize if the free surface made an angle parallel to this, then this would have been 30. Right? If this was 30, then the angle would have been 0. But the angle is 30 like this. It is like this. Right? So with the incline, it would have been 60. That is what I was saying. If you talked about this angle, then this would have been 60. Okay. So that with the horizontal, it is 30. The actual situation is like this. The water would have become like this. So that this would have been 30. This would have been 30. And with the incline, this would have been 60. Okay, got it. Now, even if it was horizontal, you realize, even if it was horizontal, then it would be making an angle of 30 with the incline, right? Now it is tilting more by 30. So with the incline, it will make 60. Now, that is what I said. Okay, I hope that is clear. Okay. Now, if we were not accelerating the vessel, if we were not accelerating the vessel, then what would have been the angle of the free surface with the incline? It would have been 30, right? Why? Because the liquid surface would have remained horizontal and the incline is inclined at 30 degrees. So, and now the liquid tilted further by 30. So, the angle with the incline would have been 60. Got it? That is what I was saying. Let me know if there is any confusion. Okay. All right. No worries. No worries. Happens. All right. So, how about this problem? Let's try this. So, again, this is based on the same concept. Okay. Here, the only problem is that the acceleration is not a linear, right? So, when you are accelerating a vessel like this, then every element is feeling the constant acceleration. Here, when you're rotating the tube, then the acceleration would not be the same for every element. Okay, along the x direction. Okay, so that's the catch here. So how do you analyze this? Let's see how you will analyze this. So try this and let me know. Hmm. So why don't you guys give this a try? Let's see. Okay, let's see if you can figure this one out. All right, let me know. Okay, I know Suraj is probably trying. Who else? Who else? You can let me know in the chat. You can let me know in the chat that you're trying. Okay. All right. So again, think about how we approach the last problem. Okay, I'll give you a hint. So there were two methods that I told you, right? So remember this method. So hint is you try, sorry, something like this. You can try something like this. Okay. All right. Let's see. So anybody? Okay. So maybe I should discuss the answer. Okay, because the longer I seem to be waiting for you guys to try it, more and more people seem to be disappearing. Okay. Okay, should I tell you or are you still trying? Let me know if somebody is trying. Otherwise, I'll just start solving this. Okay. So this is how you can do it. Let's see. Again, I can tell you two, three methods of doing this, but let's first talk about the digital method. So let's say you had this tube. Okay. Now you were rotating this about this axis, right? With some omega. Okay. Now, the centrifugal force experienced by the water molecules would have pushed them outwards, right? And that is why you see a rise in the height of the outer limb, right? So let's say this is the final situation. Finally, you have level of liquid here, okay, and then you have liquid here, and then you have liquid which has risen up to here. Okay. Now you've been told that this length is L, and this difference in height is H. Right? ये आपको बताया होगा. Okay. Now the idea is identify a few points. Okay, so let's talk about this point. Let's call this point A. Let's call this point. Let's call this point C, and let's call this point D. Okay, so let's talk about points A, B, and C, D. You know what the pressure at A is, right? And also let's say this is some. Okay. Now you know the pressure at A. Pressure at A is obviously atmospheric pressure, which is the external pressure, right? Let's say the pressure here is P naught, the pressure here is P naught. The pressures at A and B, which are the surfaces, points of the surface, will be P naught itself, right? Now, with the help of that, can I say when I go from A to D, when I go from A to D, what can I say about the pressure at D? Can I say pressure at D would be P naught plus rho H plus H, right? Similarly, I can also say pressure at C would be equal to P naught plus rho H, correct? Now, what I will do is if I go from here to here, if I go from here to here, now I know the pressure would increase. Okay. Why? Because the direction of the pseudo force, which is the centrifugal force, is outward, and we know in the direction of the external force, the pressure increases. And how much would be the pressure increase? So I can say along line PD. You realize the moment I move somewhere, I'm here in X, I'm here at a distance X, and if I move a distance dx, I move a distance dx. So, and I say the increase in pressure dP would be equal to rho ax dx. I told you this is how you find the change in pressure in the x direction. Now, what is ax? Ax is omega square x, right? That is the acceleration or the external acceleration experience at that point. So I can say dP equals rho times omega square x dx. So if I integrate this from PC to PD, and here x will vary from 0 to L. Now what I get is PD minus PC equals omega rho L square over 2. Correct? Now it's easy to see from these two equations. I can see PD minus PC is nothing but a rho GH. So I can say therefore rho G capital H equals rho omega square L by 2. And from here I can cancel this out, and what I realize is H equals omega square L over 2G, okay, which is omega square L square over 2G, omega square L square over 2G, which is option number D. So that is my correct answer. Okay. So I hope you guys followed this. This is what you do for this. Okay. I hope that is clear. If you have any confusion about this, then you can let me know. Okay, let me show you what I had written there. There, after integrating that, I had PD minus PC. Okay, nothing extra there. Okay, just go through this and let me know if you have any confusion about any of it. Okay, I hope you got the idea. I had discussed this in the last class. So if you don't know what this is, then you can watch the lecture, previous lecture. I told you that the acceleration in any direction would cause the pressure increase in that direction. Okay. So if you're not aware of this expression, then you can watch the previous lecture. And otherwise, this is the standard and traditional method of solving this. Now, there are a couple of unconventional methods of solving this also, but we are not going to delve into that. Now, another one hint I can tell you, one hint I can tell you is one which will help you solve this very easily. Okay, let me just tell you that. Now, a shortcut that you would have applied here was, you guys love shortcuts, so let me just tell you the shortcut. Okay, so now imagine this is your tube. All right, now this is water. Now, what I can do is in the shortcut, what I'm doing is now you realize in the x direction, what is the acceleration here? Acceleration here is zero. Acceleration of this point, because there is rotation happening about this axis. So the acceleration of water molecules at this end is zero. Now the acceleration of water molecules at the other end, acceleration here would be A would be equal to omega square L. And you know this acceleration increases with x in a linear fashion, right? So what I can say is, what is the average horizontal acceleration? I can say average horizontal acceleration would be omega square L by 2, right? So this is the AX average, right? Now, all you need to do is, you know that when this angle is theta, so you know tan theta would be AX average over G. Okay, use the old formula. Okay, now you will also realize that tan theta is nothing but H by L, so which will also be equal to H over L, and this will be equal to omega square L by 2G. Okay, so from here also you will get H equals omega square L square by 2. Okay. So again, now you got this without having to do any integration. So this is the shortcut. Okay, I hope you, yeah, I'm sure you guys would have loved the shortcut, right? So we can do away with the integration. Just find the average acceleration in the x direction and write tan theta as the average x acceleration over g. Okay, that's it. Okay. All right. Now let's talk about Pascal's law. Okay. So Pascal's law states that the pressure exerted anywhere in a confined incompressible liquid is transmitted equally in all directions throughout the fluid. Okay. Now this is very simple. You already know the pressure. You already know the pressure at any depth is P naught plus rho H. So if you change the external pressure, if you change the external pressure, then the internal pressure would have changed, and you would have realized delta P would be equal to delta P naught. Okay, because the liquid is incompressible, so this is not changing. The G obviously does not change, and height of that point is not changing. So by changing the external pressure, you will change the pressure of every point by the same amount. That is what the Pascal's law says. Okay. Now, in other words, it also says that at any point the pressure is equal in all directions, and the pressure exerted by the liquid is isotropic. So it also tells you that. Now, again, it also tells you that at the same horizontal level, the pressures are always same. Okay, so these are few of the implications of the Pascal's law. Now, uses are you use them in hydraulic lifts, something like this. So there you can use them as fluid. You can use this principle to leverage forces. Okay, as in a lever you do. Okay, so here you will realize what happens is that this is an example of a hydraulic lift. What you do here is that you have a stand here which has an area which is very big, and on one side you have an area which is smaller. Now, if you apply a force F1 here, then the pressure exerted or increase in pressure at this end is P1 times uh, is F1 over A1, right? Now, the same pressure increase is obtained here, okay, only that the area here is higher. So the force transmitted here becomes larger. So that's the idea. With the help of Pascal's law, I can transmit force from one point to another, and I can magnify the amplitude of the force. Okay, that is the idea. Now, why don't we try one problem again? So, like this. Okay, this is another standard problem which is asked in all your competitive exams a lot. Okay, see. So this tells you that this is the situation. Okay, you have a YouTube, and one side you have some oil, and other side you have water, and you have been told that this will be 13.5. Would it be? Could it? 135. Tried out, but whatever. So here is the question that has been told to you. So at on one side you have water, and on one other side you have oil, and the height of water column is 13.5 mm. The height of oil column above this level is 12.3 mm. So you have to find from this figure what is the density of oil. Okay. So try this. Try this. So let me give you 1 minute to try this, and then I will start to solve this. Okay. All right. Let's see. Let's see if we can figure this out. Try this. This is an easy one, very standard problem. I'll tell you. Hint is that at the same horizontal level, the pressure in every liquid is always the same. Okay. Or I can tell you a very, very simple trick. Okay. Okay. So are you guys trying, or should I just solve it? Okay. I don't think too many of you like trying questions. Okay. I don't know whether it is you feel lazy about it, or I don't know. All right. So the idea is, I'll tell you the trick. The trick is, if you look at this point, you look at this point, right? So for this point, what you realize is that the pressure obviously will have one value. Okay, so you can arrive at this point from this route, or you can arrive at this point from this route. You should always get the same pressure, right? That is the idea. The pressure here, so let's call it pressure PA, would be same whether you come from left limb or whether you come from the right limb, right? Now, if the pressure here is same, then you can say that the pressure here and here would also be the same, right? Because this side is same at both the points. So you realize the pressure here and here will also be the same. Okay, so that's the idea. So all I can say is PB, if that is the pressure at this point, and at this point the pressure is PC, then what I can say is that PB will be equal to PC. Okay, I hope that's clear. Yeah, that you should be able to see easily from the figure. From the figure, we can judge that PB should be equal to PC. Correct. Now let's talk about the values. The pressure at B would be here. The pressure would be P naught. It would be P naught plus 13.5 times a row of water. Okay, so I can say also P is P naught plus 13.5 it is. So into 10 to the power minus 3. Okay, a row of water times G. And what is PC going to be? PC is going to be 13.5 plus 12.3. So that is going to be 25.5, 25.8. So 25.8 times P naught plus 25.8 times 10 to the power minus 3 row of oil times G. So all I need to do is just equate these two. And when I equate these two, what I get is row of oil is equal to 13.5 over 25.8 times row of. So that is going to be your answer. Okay, row of water we already know is in SI units is 1000 kg per meter cube. Okay, so this is going to be my answer. Okay, I hope everybody is fine with this. So very simple. Just look at this. Let's go over this one more time. So whenever you have such a situation, you realize if you the pressure here is P naught, the pressure here is P naught. If you come down from here, okay, to this point, the pressure will be PA. If you come down from this point, again the pressure would be PA. Okay. Now if the pressure on both the sides is PA, so at this point, which is at equal heights from both the limbs. So if this is H, if this is also H, so you realize that pressures here would also be equal. Okay, because here the pressure would have increased from here to here by rho GH of water, right? So that is the entire idea. Once you realize that if this is point B and this is point C, then pressure at B will be equal to the pressure at C. Now solving the question is very easy. Okay. So that is all we did. That was the logic that we used. Okay. And this is the answer that we are getting. Right. So let's talk about another question then. This is a direct application of Pascal's law. You have been told for the system shown in the figure, the cylinder on the left has a mass of 600 kg and a cross-sectional area of 800 centimeters square. Piston on the right is at S has a cross-sectional area of 25 centimeters square and negligible weight. If the apparatus is filled with oil of density 0.78 gram per centimeter cube, what is the force required to hold the system in equilibrium? So you realize this 600 kg block would be pushing it down. So to keep holding this, you would require to apply some force F. So that has been asked. What is the force F required to just hold it down? So all you need to realize is that again the pressure here and the pressure here would be the same, right? And the pressure here would be equal to the external pressure here P naught 1, let's say, because of this, and here P naught 2 because of this. Okay, so all you need to do is equate the pressure at the same horizontal levels. What I can say is that pressure here is P naught 1. So I can say P naught 1 should be equal to P naught 2 plus rho GH. Now P naught 1 I already know. It would be 600 over 800. So 600 to 10 over 800 to 10 to the power of minus 4. and this should be equal to P naught 2. P naught 2 is F. F is the force that I am applying over the area of cross section, which is 25 into 10 to the power minus 2 plus rho GH, and that will be 0.78. So let's multiply that with 1000, 780 into 10 into the height, which was 8 meters, right? So this is how I would solve this one now. Okay, I can solve this equation and find the value of F. So that is the force that I need to push the other end with in order to hold the system in equilibrium. Okay. I hope that is clear. Okay, did everybody follow this? Now all I need to do is solve this and find the value. This okay. Okay. So let's move on then. Now let's finally talk about Archimedes principle. So today's lecture was all about Archimedes principle. Okay. So let's get started with this topic. Now, Archimedes principle, the famous principle given by the crazy man Archimedes, says that a body, when submerged in a fluid, partially or completely, feels a upward force, a net upward force due to the liquid. Okay. Now, this force is known as the buoyant force, and it is always equal to the weight of the liquid displaced. Okay. So, buoyant force is equal to rho Vg, where V is the volume of the liquid displaced, rho is the density of the liquid, and G is, of course, the acceleration due to gravity. Now, the single point at which this buoyant force can be considered to be acting is called center of buoyancy. That is the average position of this entire buoyant force. So, you know that on an average, we apply the force of gravity, mg, on today's day is just getting worse. Why? What happened? What happened, ARJ? I hope everything's fine. Okay. So as I was saying, that you know that the average position on which at which the entire weight of new object acts, that we call as center of gravity, right? Similarly, you have center of buoyancy, which is the average position of the entire buoyant force, which will obviously be the center of gravity of the liquid displaced. Okay. Now, this law explains the loss in weight of objects submerged in liquids and the flotation of objects in liquids. Okay. So I don't know what happened to ARJ. Why is he feeling so lost? Now let's talk about the proof. Okay, so school is reopening on 11th from 8:30 to 3:20. Now I'm confused when to do backlogs. Okay, so you realized I don't think they would have compulsory attendances in school right now. Okay, and hopefully your syllabus, school syllabus, must be over. So I think all you need to do is just go for the practicals and skip the rest. Okay, I'm sure they won't consider, they won't want to keep the attendance compulsory right now, right? They, I'm sure, can't have the attendance compulsory without everybody having gotten the vaccine. Okay, so that's not such a big issue, यार ARJ. छोटी छोटी बातों से ऐसे नहीं परेशान होते. Okay, don't worry about it so much. It's all right. It's all good. All right, so let's talk about the proof. Okay, so imagine this is a container which contains a liquid. Now, inside the liquid, let's imagine I have put an arbitrary body. Say I have submerged some body like this. Okay. Now, all I need to do is that forget about having this body here. So imagine I had submerged this body. I had submerged this body in the liquid, and I want to know what kind of force it is feeling. What kind of force it is feeling due to the surrounding liquid. Right. Now think about this. Think about this. Now, if I just remove the body, imagine hypothetically, if I could just remove the body and leave that space and fill that with water, if I could take out take out the body and leave that space vacant and then fill that with the same liquid. Imagine it was also that liquid only. Now, what you can say is, okay, so ARJ seems to be having a lot of troubles today. Okay, it isn't compulsory, but they will deduct it from 100% attendance. I have around 91%. They have completed syllabus, but I don't know about when I should do 12th and when 11th. Very confused. So one request, could you take electrostatics in quick reviews? Yes, absolutely, I will. I will, ARJ, don't worry. Okay, so as I said, I think you mentioned your boards are in May, right? Yeah. Your boards are in May, right? So if your boards are in May, I think for the first 2 months, Jan and Feb, I think you can focus on your mains, and then March and April you should focus on boards. Okay. So I hope you've already prepared for your 12th. Okay, कुछ तो पढ़ाई की होगी ना? I am sure you must have studied something, right? So 2 months should be good enough for boards revisions. In any case, how many subjects do you guys take in boards? Like 4 and 5, right? So I don't think that should be that big a problem. So focus, give these 2 months for it isn't compulsory, but these 2 months for mains, okay, Jan and Feb, give your best in the Feb and the March attempt. And then for the next 2 months, focus on the boards. Okay, that is what I would advise you to do. Okay. Now, when you say that it isn't compulsory, but they'll deduct it from 100% attendance, so what does that mean? What does that mean? How can they have anything to do with attendances this year when no schools are opening? So I don't think that they can do anything about the attendance this year, ARJ. Don't worry about it. In this year, they cannot ask you to come to school and deduct your marks if you don't come. See, your safety is your concern. At the end of the day, you can refuse to come. You can say, I'm worried about my safety. Can they guarantee that you'll be safe if you go to the school? No. So of course not. They can't deduct marks this year at least. Maybe in normal circumstances they would have. But this year, don't worry about it. You'll be fine. Okay. All right. Okay. Okay. So what is up with RDX gaming? क्या हो गया भाई? This is the channel for studies. Please do not try to disturb students here. ठीक है भाई. Hmm. Okay. All right. So as I was talking about the proof, let's tell you. So imagine if instead of the body, if you just had a vacant space and a liquid filled in that. Now you realize the surrounding liquid would have still applied the same amount of forces at all points because the pressure at all points would have been same. The surface is the same. You realize the surrounding liquid force would have been exactly the same had the space been filled with an outer object or the space been filled with the liquid itself. Okay, so that is the proof. So I can say, so when a solid is submerged in a liquid, okay, now what we are trying to do is that if I remove the solid, if we remove the solid, or if we assume that the volume of the solid was filled with the liquid itself. So all you have to do is just imagine that. You imagine that these boundaries are there, but instead of the solid being inside that volume, there was this liquid itself. So you realize this liquid would have been in equilibrium, right? Now, for that to happen, because of that, because of which we can conclude that the net force applied by the surrounding liquid must be equal to the weight of the liquid. Okay, so that is the idea, right? So that is the theoretical proof. You can theoretically argue that if in that boundary, instead of that solid, if the liquid was contained, then that liquid would have been in equilibrium, right? Every part of you can think about this like this. So you consider any part of the liquid which is there. Okay, you consider that. Well, let's say you consider another random part of the liquid. This random part of the liquid is also in equilibrium at all times. If it is also in equilibrium at all times, what does that imply? That implies that the net force by the surrounding fluid must be equal to the weight of the liquid contained in this area, correct? Imagine whatever liquid is contained in this area, it is feeling two kinds of forces. One, it is feeling a net force of gravity, kmg, and then it is feeling a net force due to surrounding. Now, the net force due to the surrounding liquid must be exactly opposite, equal and opposite to the weight of the liquid. That is why this portion of liquid is in equilibrium, correct? So, this is the force due to surrounding liquid. Okay. Now, you realize if instead of the liquid being there, there was a solid, then you realize for the boundaries, nothing changes. At all points of the boundaries, the pressure would still be the same and the surface of the boundaries would still be the same. So the force by the surrounding liquid cannot change. So the force would be equal to the weight of the liquid displaced. That is the logic. Okay. Now, suppose there were a body which is submerged in two liquids. Now, this has been a favorite topic for IIT Advanced. So they ask you something like this. So they tell you that there is a container, okay, a side container here, and it has two liquids, right? And a body is submerged so that it is partially in one liquid and partially in the other liquid. So imagine there was one liquid like this, and then on top of this there was another liquid. Right. Now imagine there was a body which was partially submerged in liquid one and partially submerged in liquid two. Okay. So imagine. And this is the kind of question that has been asked in JEE. So imagine there was a solid which was like this. So the net force experienced by this solid would obviously be equal to the weight of the both the liquids displaced. Okay, now please remember this. that I can easily conclude that the net buoyant force experienced by this liquid would be equal to the weight of both the liquids displaced. But where is that coming from? Where is that coming from? You will realize that the upper liquid is applying a downward force due to all its pressures, and the lower liquid will apply a much higher upward force. So the net force is actually being provided by the lower liquid only. Okay, so that is what you need to understand and get in your head. Net buoyant force experienced by the solid will be equal to the weight of both the liquids displaced. So that's the first thing that we can see. Again, by the same logic as we used in the last explanation, right? So if this entire space was filled with those two liquids only, then those two liquids would have been in equilibrium. The net force would have been equal to the weight of those two liquids which are being displaced by the solid. Now, however, you realize the upward liquid will only apply a downward force due to all the pressures, and the downward liquid, the second liquid, will provide an upward force. So the net, all the upward force is actually being provided by liquid two only. Liquid one is actually providing a downward force in this particular case. So if this is liquid number one, this is liquid number two. So you can conclude that, however, in this case, however, in this case, liquid one applies a net downward force to solid, and the entire upward force is provided by the lower liquid, or provided by liquid two. Okay, so please remember that. All right. IIT JEE Advanced has asked a question on this, and that is why this is very relevant, okay, and very, very important. Just remember this. Okay. Now let's move forward, and why don't we try a problem on this? Okay. So let's see. You've been told a metallic sphere floats in an immiscible liquid mixture of water and a liquid of specific gravity 13.5, such that 4/5 of its volume is in water and 1/5 volume is in the liquid. Find the density of the metal. Okay, so let's see. Let's see how you can do this. Okay, try this. Okay, hurry up, hurry up. Let's try this quickly. Let's see how many of you can figure this out. Okay. So anyhow, let's do this. So I told you the total buoyant force would be the weight of the liquids displaced. So imagine if the volume of the solid is V. So let's let the volume, let the total volume of the solid be V. Then the volume submerged. Okay, Muhammad Naman is saying, sir, where can I complete my theory from all subjects as I have less time? I can't watch videos, any books or sessions, please. So, Muhammad Naman, what you can do is you don't have to watch the long videos. There are one shot videos available. There are quick reviews videos that we are taking here. Maybe you can watch those, Naman. Okay. Trust me, reading books will take more time. Watching videos will be a shorter, practice. You can watch the quick review videos. Okay. So there are a lot of quick review videos and one shot videos, no, that we keep taking. We are taking a quick review series. So where I have finished every topic within almost 2 to 3 lectures. Okay. So what you can do is you can watch those videos. You can even watch those in 1.5x speed. Okay. Because if you're only looking to revise, then you can even understand those at 1.5x speed. So that will save you time. So that is my advice to you. Okay, Mohammad Naman. If you want to revise your complete theory, then that is what you should do. Watch those quick review videos and watch them at 1.5x speed. That will save you some time. Maybe of the important points, you can keep making notes. Okay. Whatever important points you feel, you can keep making notes of those. That is my advice. Okay. Now, coming back to the solution of this question, let the total volume of the solid be V. Then, according to the question, what I realized is 4/5 V is in water. Then, according to the question, what I realized is volume of water displaced will be 4/5 V, and volume of liquid displaced would be V over 5. Correct? So I can say that. That is according to the question. Now I know if this is floating, then it must be in equilibrium, right? So if this is floating, okay, for floating, I can say so point force must be equal to weight of the solid. That is the condition for flotation, right? So now all you need to do is therefore the rho of solid into G should be equal to 4/5 the rho of water to G plus 3/5 rho of liquid into G. Okay, so from here VG cancelled out. And what you're getting is that rho of solid is actually equal to 4/5 the rho of water, which is 1000 plus 1/5 into 15.5 times 1000. Okay, so rho of solid actually comes out to be, let's take 1000/5 common, 200, and inside you have 4 plus 13.5. So you have 200 plus 17.5. 17.5, 3500 kg per meter cube. That will be the answer. Okay. All right. So this is how you would have solved this. Okay. I hope everybody followed this. Okay. This is 17.5 into 200. Okay, that'll be 3500. Okay. Now you can have another problem. This is another conceptual problem. Okay, you think about this. We will discuss this in the next class. We have run out of time for today's class. Okay. And I had a few more problems that I wanted to discuss, but we will discuss those problems in the next session. Okay. We have run out of time for today. So this is where I would like to wrap up today's session. And before I leave you guys, let me remind you, if those of you who are still planning to get their Unacademy Plus subscriptions and haven't gotten them and are wondering how to go about this, can do this. So it is very easy to get your Unacademy subscriptions. All you need to do is install the Unacademy app. Once you have that, go to the plus section of the app, select your goal as IITJ and click on that get subscription button. All right. Now, when you are redirected to the payment page, don't forget to use the code RD Live. Okay, in a box which will say, do you have a code? So you use this code and you can get yourself 10% off. Okay. Now you can also choose from two kinds of subscriptions, the plus subscription or the iconic subscription. And also when you click on proceed to pay, you will realize that you can choose from a lot of no cost EMI options. All right. Also, you will realize that the pricing of these subscriptions is already kept very, very competitive. So the 12-month subscription comes to about 2,800 a month, and 24-month subscription comes to about 2,100 a month. At these prices, the kind of quality content that you're getting, the kind of teachers that you're going to study from, it is completely worth it. Okay. Now moving forward, let's tell you a bit about the iconic subscription. The iconic subscription takes your IITJ preparation to the next level. Okay, this will be allotting. So when you get yourself the iconic subscription, you'll be allotted personal coaches from a team of experts. So these personal coaches will guide you and closely monitor your performance and your JEE preparation throughout your JEE journey. Okay, so they will keep on mentoring you on a very, very personal basis. Next, you also have a timely IITJ workshops that you'll be attending. Then you'll also be receiving expert guidelines. And of course, you have a study planner. And then you also be a part of test analysis sessions. Okay. So please remember that with all these benefits, you can obviously get your JEE preparation very, very easy. Okay, so this subscription is mainly meant for students who I think need more personal attention or feel the need for more personal attention while they're preparing, because I know a lot of students feel comfortable with more personal attention. So this is for those students. You guys can go for the iconic subscription. All right. Next, again, as I said, you can also go for combo subscriptions now. So Unacademy is also offering you combo subscriptions. So this is a one-stop solution for all your worries about your boards or your JEE. Now you have combo of the JEE and the board subscriptions. Okay. The first combo is giving you the iconic subscription of IITJ and the plus subscriptions of 11th and 12th. This combo starts at 46, roughly 4,600 a month. Then you can go for an iconic combo for all three, and this subscription starts at 5,500 a month. Then you can go for a plus subscription of all three. This one starts from 3,000 a month. And then finally, you could have gone for plus subscription for IITJ and iconic for your 11, 12 J, boards. Then this subscription would cost you somewhere around 3,900 per month. All right, so do check these combo subscriptions out. And again, also don't forget about taking part in the next Unacademy Combat, which is going to happen live on the 17th of Jan. So take part in it. You can enroll now using the code RD Live and win yourself some really cool prizes and rewards. All right. Now, those of you who are following us on the JEE English channel of YouTube, don't forget to connect with us on the Telegram app using this link so that you're receiving all the notifications of all the lectures and sessions happening on this session, this particular channel of YouTube. All right. With that, I'll take your leave. And before I leave you, let me remind you one last time that this is my code RD Live. If you're planning to get your Unacademy subscriptions, you can use this code and enjoy a 10% off on all your subscription fees. Now, with that, let's conclude today's discussion, and we will carry forward this discussion next Monday now. Okay, where we will talk about applications of Archimedes principle and what are the scopes of different kinds of problems that you encounter. All right. So till then, you guys keep studying hard and keep practicing. Okay? And definitely don't forget to take good care of yourself. All right. Bye bye. Take care.